Chapter 3, Section 2, Climate, Weather, and Life. Learning objectives. Explain how weather and climate differ. Describe how Earth's climate and average temperature are determined. Explain the causes of ocean currents. Identify the factors that shape regional climates. Explain the processes involved in climate change. Climate and weather. Because weather and climate are so important, it is worth looking at them closely. Weather consists of short-term changes in temperature, precipitation, clouds, and wind from day to day or minute to minute. Weather can change rapidly and can be tough to predict. It may be sunny in the morning but rainy in the afternoon. Climate is defined by patterns and averages over many years of temperature, precipitation, clouds, wind, and extreme weather events such as heat waves, droughts, and floods. There are many factors that make up climate. Climate is more predictable, so you could expect it to be hot in certain regions and cool and foggy in others. Weather and climate shape natural populations, communities, and ecosystems. Either short-term weather changes, such as droughts, or long-term climate changes, such as frequency of droughts, can mean the difference between success and failure of things like crops. The global climate system. Climate and weather are produced by the global system of winds and ocean currents. Earth's global climate system is powered and shaped by the total amount of solar energy retained in the biosphere as heat and by the unequal distribution of the heat between the equator and the poles. The components of the Earth's climate system is controlled by the cryosphere, the geosphere, the hydrosphere, the biosphere, and the atmosphere. Solar energy and the greenhouse effect. Solar energy arrives as sunlight striking Earth's surface. Some of the energy is reflected into space and some is absorbed and converted into heat. Some of that heat radiates into space and some is trapped within the atmosphere. Earth's average temperature is determined by the balance between the amount of heat that stays in the atmosphere and the amount of heat that is lost into space. This balance is largely controlled by the concentrations of three gases in the atmosphere: carbon dioxide, methane, and water vapor. These gases are called greenhouse gases because they act somewhat like the glass in a greenhouse. The gas allows visible light to enter, but they trap heat like they would in a greenhouse. The phenomenon is called the greenhouse effect. Without the greenhouse effect, Earth would be about 30 degrees Celsius cooler than it is today. These three gases enter and leave the atmosphere as part of the global cycles of matter. Their concentration in the atmosphere can therefore be affected by changes in these cycles driven by non-human causes and by human activities. If changes in these cycles increase, the greenhouse gas concentrations in the atmosphere retain more heat, and Earth warms. If changes decrease, greenhouse gas concentrations allow more heat to escape, and Earth cools. The greenhouse effect on Earth. The greenhouse effect allows visible light to enter, but allows heat to be trapped. Go ahead and draw the diagram now. Latitude and solar energy. Because Earth is curved and tilted On an axis, solar radiation strikes the surface at angles that vary from place to place and from one season to another. Earth's curvature causes some amount of solar energy to spread out over a large area near the poles than near the equator. Near the equator, the sun is directly overhead at noon, and day length varies little over the year. North and south of the equator, the sun drops lower in the sky during the winter as the tilted Earth revolves in orbit, and the days become shorter. For both these reasons, more solar energy per unit area and therefore more heat arrives each year near the equator than near the poles. The heat distribution creates three main climate zones: tropical, temperate, and polar. Draw this diagram in now as well. Global winds. The unequal heating of the Earth's surface creates winds and ocean currents. Air that is heated in a warm area, such as near the equator, expands, becomes less dense, and rises. As the air rises, it spreads north and south, losing heat along the way. As the air cools, it becomes more dense and sinks. Meanwhile, cold air over the poles also sinks. This pattern of rising and sinking air creates circulating cells of air that rise, travel north and south, sink towards Earth's surface, warm, and then rise again. As that air travels from place to place where it sinks to places where it rises, it creates winds. Earth's rotation causes winds to blow from west to east over both land and sea in the temperate zones, and from east to west over the tropics and the poles. Ocean currents. An oceanographer might say that ocean currents would flow around the world in much the way global winds do, but those pesky continents get in the way. Ocean currents are driven and shaped by patterns of warming and cooling by winds, and by locations of continents. Prevailing winds blowing over the ocean surface, currents that profoundly affect the weather and the climate. The warm Gulf Stream, for example, travels north along the east coast of North America, carrying heat from the Caribbean and the Gulf of Mexico. Air passing over the Gulf Stream picks up moisture and heat, moderating winter temperatures in the coastal areas. Along the west coast, the cool California current carries cold water southward, cooling the Pacific Northwest and the California coast. These interactions between atmosphere and hydrosphere shape weather and climate on land, and also influence water temperature and salinity that affect marine organisms and communities. Regional climates. Northern California, Nevada, and Utah are located in similar latitudes and are affected by the same prevailing winds, yet the coast of Northern California has a very different climate than Nevada. Because of the coastal ranges and the Sierra Nevada, this gives it a very different climate. Regional climates are shaped by latitude, by the transport of heat and moisture by winds and ocean currents, and by geographic features such as mountain ranges, large bodies of water, and ocean currents. Coastal California is cooled and humidified by cold surface currents and prevailing westerly winds. That moist air first hits the northern coast ranges and then the Sierra Nevadas. In both places, that air is pushed upward and cools, causing moisture to condense and form clouds. Those clouds drop rain or snow, mainly in the western side of the mountains. For that reason, Coastal Northern California and the western slope of the Sierra Nevadas are cold and moist, supporting redwood forests along the coast and Sequoia inland. East of the Sierra Nevada, air that has lost most of its moisture sinks to the lower altitudes, warms, and dries out even more. As a result, east of the Sierra, Death Valley bakes in the desert sun. Changes in climate. Earth's climate has remained pretty stable during recorded human history. The patterns of clouds, deserts, and the green areas could be taken from any tropical day over the last few thousand years, but global climate has changed dramatically over a much longer history of life. Earth's average temperature has increased and decreased over periods ranging from tens of thousands of millions of years. Those changes in global temperatures affect both the structure and the function of the global climate system. Recall that climate involves a lot more than just temperature. It also includes winds, precipitation, clouds, and extreme weather events. Climate change therefore involves more than global warming and cooling. Climate change involves changes in temperature, clouds, winds, patterns, and the amount of precipitation and the frequency of severe and extreme weather events. Non-human causes of climate change. Several factors have caused long-term changes in regional and global climates. These factors include changes in solar energy, variations in Earth's orbit, meteorite impacts, changes in the distribution of continents and oceans, mountain building, volcanic activity, and meteorite impact. Here's how the sun's output of solar energy varies over time. Earth's orbit around the sun and the tilt of Earth's axis changes slowly. In the cycles about 100,000 years, the positions of Earth's continents also changes very slowly over millions of years, affecting patterns of both winds and ocean currents. Episodes of mountain building can cause dramatic changes in regional climate by affecting temperature patterns and precipitation. Major changes of the amount of volcanic activity worldwide can cause changes in the concentrations of greenhouse gases in the atmosphere. And once in a while, a giant meteorite strikes, like the one that led to the dinosaur extinction around 65 million years ago.